Okay, so in this video here, we're going to be talking about how to find the inverse of a logarithm. And the inverse of a logarithm will always be an exponential, and the inverse of an exponential will always be a logarithm. Now, I have a video on how to take the inverse of an exponential, so I'll go ahead and link that below. That way you have access to that content. But in this video here, we're going to be going in reverse, and we're going to be getting the inverse of a logarithm. So what you want to look at are your equations over here. Now the equations in red, they are exactly the same. So for example, these equations right here are exactly the same, except one is in log form and the other one is in exponential form. So we can take a logarithm and we can write it as an exponential. A logarithm has an exponential form, and that's what you're looking at right here, x equal to by. This equation will result when you find the inverse of an exponential. So when you take the inverse of an exponential, this is what you end up with. But we never want to leave it in its exponential form. We then put it in its log form. Again, these are both the same. So if you were to graph them, they're going to give you the same exact function, okay? But what we want to do here is go from log to exponential. So for example, before you do anything, you want to make sure that your logarithm is isolated. And when I say logarithm, I mean that you should have your log, your base, and then your x. That's it. Okay. Anything else, you'll have to go ahead and move over to the left-hand side. But on this example here, I'm good. So what we're going to do, we're going to go from log and we're going to put it in its exponential form that we see right here. Okay. So to do that, I'm going to rearrange everything. I'll have x is equal to 2 to the y power. Again, this is like my x here. This is my base, and here's my y, right? So just using the equation to the left here, I'm just rearranging it. And from here, what you want to do is actually take the inverse. So now that you have the logarithm in its exponential form, you want to switch the x and the y, and then you'll solve for y. When I switch the x and the y, I get the following. I get y is equal to 2 to the x power, and y is already solved for. So this problem is done. Here is the inverse of that logarithm. You're going to have y is equal to 2 to the x power, okay? So that one was pretty straightforward. Let's go ahead and try some more that are a bit more tricky. So here's our next example. And again, you want to make sure that your logarithm is isolated. Now, my base here is actually 10. They don't write it, but remember, whenever you have a logarithm and they don't write the base, by default, it will have a base of 10. So I'll go ahead and write it in there. And my x is actually this entire part here in parentheses. Here's my x. So my logarithm is actually isolated. I'm going to go ahead and put it in its exponential form. When I do that, this entire part here, x plus 4, will go to the left-hand side. So when I rewrite it, I'm going to get x plus 4 equal to 10 to the y power, okay? So now from here, now that I have it in its exponential form, I'm going to go ahead and switch the x and the y, and then I'll solve for y. So making the switch, I get y plus 4 equal to 10 to the x power. And then solving for y, I get y is equal to 10 to the x power minus 4. And here it is. So here is the inverse of that particular logarithm. All right, let's go ahead and try another example. So here's our next example. And again, first step, make sure that the logarithm is isolated. Now on this one here, it's not. I have this plus 2 on the end. I'm going to have to go ahead and get rid of that before I do anything. So moving that over, we're going to subtract 2, meaning I'm going to get y minus 2 equal to log, and then base 2 of x minus 2. So now my logarithm is isolated, and again, you may want to identify all your parts here. This entire part here is going to be x, okay? My 2 is my base, and this whole part here is actually going to be like my y. So this whole part is my y. So rearranging it now into its exponential form, I'm going to have x minus 2, that's my x, equal to my base, so 2, and then all to the y, and remember my y here is y minus 2. So I get y minus 2. So now I have it in its exponential form. I'm going to go ahead and switch the x and y values. So I'm going to get here y minus 2 equal to 2 to the x minus 2. And then solving for y, you get the following. You get y is equal to 2 to the x minus 2, and then plus 2. And here you go. We're done. All right, so there's the inverse of that logarithm. Let's go ahead and try one more example. So here's our last example. Again, we want to make sure that we isolate the logarithm. So I want to isolate this part here, meaning I'm going to have to add 3, and then I have to get rid of that denominator. So first I'm going to add 3. I'll get y plus 3 equal to log, and then of x plus 1. And remember, this logarithm has a base of 10. They don't write it in, so if you want to write it in, you can. It does have a base of 10. And then all over 2. So think about how you can get rid of that denominator. Well, we're going to multiply by 2. So I'm going to multiply both sides by 2. That will cancel here. But I also have to do it to this side here. Okay. So remember, this 2 has to go to both of your terms, so you have to distribute. Now, I'm going to go ahead and rewrite it as 2y plus 6 equal to log base 10 of x plus 1. Okay. So now your logarithm is finally isolated. Now we can go ahead and put it in its exponential form. So remember, this entire part here is my x, and this entire part here is going to be my y. Okay, so let me go ahead and scroll down just a little bit, and rearranging it, I'm going to get the following. I get x plus 1, that's my x, equal to my base 10 all to the power of y, which is 2y plus 6. So 2y plus 6. And then we have to go ahead and make the switch now. So we're going to go ahead and switch the x and y values. So now I get y plus 1 equal to 10 to the power of 2x plus 6. And then finally, solving for y, you get the following. You get y is equal to 10 to the power of 2x plus 6. And then moving over that positive 1, you get minus 1. Okay, and here we go. That is done. So there's the inverse of that logarithm. So that is it. That is how you can find the inverse of a logarithm. It's pretty straightforward. Just make sure that you're using those equations. And remember, when you're taking the inverse of a logarithm, you always have to put it in its exponential form first, and then you can go from there by switching the x and y values. All right, so that's going to do it. I hope that you found the video helpful. I hope that you gained something from it. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that'd be greatly appreciated. Also, make sure you subscribe. That way you get more math videos in the future, and I'll see you in the next one.